Hi, it's Mrs. Green, and this lesson is changing fractions to decimals. We're not going to do it the other way around just yet. We're not going to change decimals to fractions. That's a different lesson, not to be confused with decimals to fractions. Today we're just going to do fractions to decimals. It was going to be too big of a lesson to do both in one sitting. All right, so you've got your prior knowledge already written down, and here's your key information. So I want you to have a few definitions. One of them is the definition of a rational number. And a rational number is a number that can be written as a ratio. So you might notice the word ratio is embedded in the word rational. So that's one way. I like to use words as hints for helping me remember things. So, a threat has been detected on my computer. Oh well, on my other computer. So it's a number that can be written as a ratio, or a quotient is another way to say ratio. It's using division of two integers. So what that would look like is 2 over 7. That's a rational number. And I might be writing a ratio. I might be saying I have 2 of something to 7 of something else. I might be comparing 2 cars to 7 bikes in the parking lot. That's a ratio, as a comparison of two things. It also uses division, so the fraction bar is a division symbol, and that's why they're saying quotient. So that's a rational number, and that's the words. The words are up here. Numbers looks like that, and algebra looks like this, A over B. So you've got words, numbers, and algebra, and then we have a little extra technique or a little extra piece of information for the algebra. Remember, B cannot equal 0 because then it would be undefined. So that's a piece of algebraic information they usually give us when we're talking about rational numbers that have a denominator that can't be 0. So there you have your definition of rational numbers in words, numbers, and algebra. I also want you to write this information about how you should convert a rational number into a decimal. So you can do that. You can convert a rational number as a decimal by doing division. So you divide the numerator by the denominator, and then you can get one of two results. You can get either a terminating decimal. So this isn't exactly the definition of a terminating decimal, but it's the terminating decimal part is embedded in this information. And we know that's a decimal that's going to stop and have no remainder. Or you can get a repeating decimal. And in my two examples on the next page, I'll show you how that works. So for now, you need to know that whenever you convert a rational number that looks like a fraction, so let's say we have 5/11ths, and you want to convert that into a decimal, you're going to do division. So you're going to do 5 divided by 11. Or you're going to make it into a long division problem, and we'll do that example on the next page. And then it's either going to end up being a terminating or a repeating decimal. All right, another piece of key information. I want you to draw this diagram of real numbers. And this is a nice picture. There's a picture just like this, very similar to in your blue textbook. There's not a picture, I don't believe, in the red textbook. But this is a good graphic which shows the relationship between rational and integers and whole numbers, and then where the irrational numbers fall. And so I'm going to write some examples in each of these boxes of these different types of numbers. So the whole numbers are the counting numbers plus 0. So you've got 1, 0, 4, 27, any number you can use to count with, and also 0 is a whole number. And the integers are the whole numbers and their opposites, so integers would include -1, -4, -27, and then also the positive whole. So whole numbers are part of integers, and then integers take it one step further, and they're the opposites. So whole numbers are the counting numbers and 0. Counting numbers plus 0, including 0. You don't usually use 0 to count. You start with 1. So we have to put 0 in as a whole number, and then the integers are the whole numbers. There's the number symbol. And they're opposites. We've talked about opposites before. So integers are the whole numbers, and they're the negative whole numbers, the positive and negative whole numbers. And then rational numbers are what we're talking about with these fractions. And rational numbers are going to be fractions. By definition, a fraction is a ratio, so it's a rational number, ratio. And also, since we can convert rational numbers into decimals, you're going to have terminating decimals, which we talked about on the last page, and repeating decimals. So terminating and repeating decimals. So you need to draw your picture big enough to fit all this stuff in. Those are part of the set of rational numbers. Repeating decimals and terminating decimals also belong in the yellow circle of rational numbers. So what does that leave us with irrational numbers? What the heck is left? Irrational numbers are decimals that do not repeat or terminate. Decimals that do not repeat or terminate. So those are decimals that go on forever and ever. And there's a couple of very popular decimals that do that. One of them is pi. That's one of the most popular decimals that it just goes on and on and on forever. The other thing that's typically you'll find is a root. This is a square root. We've not talked about this year, but I'll just write it down here, and then we'll go back to talking about irrational numbers when we get to square roots. But it has to be a number that's in here, like 3 or 5, that's not a perfect square. So the square root of 4 doesn't work, because that, if you simplify it, actually is 2. So that is not irrational. That's actually a rational number, because it becomes a whole number. But if the number underneath is not a perfect square, so 3, 5, lots and lots of different numbers, if you plug that into a calculator, if you take the square root of 3, it would be a decimal that does not repeat or terminate. So there's not a whole lot of irrational numbers. There's just really 2 categories, pi and then the square root of a non-perfect square. There are others, but those are the main ones that you'd see on a test. Oh, you know what? One more. Sometimes it can have a pattern. A decimal can have a pattern, like 0.01010001000. So see, there's a pattern. I'm adding a 0 every time between the 1. But this is not considered a repeating decimal, because it's not the same digits that repeat. It's just a pattern. That is also would be an irrational number. Okay. Example 1 is going to be 5 over 11, and I'm going to make a long division problem. And sometimes we don't remember, but the denominator is the one that goes on the outside. The numerator goes inside the house. I don't know how you guys were taught this before. However you remember it is a good way to remember it. And I need to add, I don't have enough in 5 to go, 11 can't go into 5, so I've got to add some zeros. So now I've got 11 goes into 50 4 times, which is going to give me 44. And I'm just doing long division. This is long division. You know how to do long division. Let's see, 11 goes into 65 times. 55, 0, 50. And then we're back to 4. So you can see this is going to repeat. 6, 0. So I keep adding zeros and bringing them down. And that's going to go on forever. And then I'm going to get another 5. So 55. And I'm going to get 5 again. And it'd be 45. And so that's a repeating. So I'm going to use the bar above the 4 and the 5. Those are the 2 digits that repeat. You can also write it as 0.4545 ... Example 2 is 7/20ths, and I'm going to set up a long division problem. 20 goes on the outside, the 7 goes on the inside. If you set this up wrong, you'll probably get a whole number. And when you look at your original fraction, it would not make sense. This is smaller than 1, 7/20ths. It wouldn't make sense if I got a whole number. Like if I set it up wrong, so this is wrong. You can use your common sense. That's going to go in 2 times b. So I'd have 2 point something, which is a whole number. And that my fraction is not that big. So I know that that would be wrong if I set that up. I'm expecting a decimal. So I already have to add some zeros. And now I've got 2 going into 7 3 times. 20 going into 70 3 times. So that's going to be 60. Bring down the 0. And then I've got 2 going into 100 5 times, or 2 going into 10 5 times. 20 going into 100, or 2 going into 10. That's going to be 100. So that stops, no remainder. And that's what I'm looking for. So that's a terminating. So you either have a repeating decimal, like here, repeating, or you have a terminating. If you don't have those, it wasn't a fraction to begin with. It's not a rational number. All right, I found a picture of our little teacher lady here, and she has a shortcut. This is another way you can change another way you can change a rational number, a fraction, into a decimal. If, you can see in her example, if you have a nice round number in your denominator that is a factor of 100 or 10 in any multiple of 10, you can convert it like she's done here. Multiply by 25 over 25, and that's going to give you 100 on the bottom, and then whatever ends up being on the top, 75 in this case. Now you can convert that easily to a decimal, because that's 75 100ths. And if you say that out loud, 75 100ths, you know the decimal has to go in front of the 7. That's what 75 100ths looks like, and you're done. So that would be a quick, easy way versus for dividing it long like this. Either way, you're going to get 0.75. But if that denominator goes into 10 or 100, 100 is more of a common number. It's got more factors, I guess, than 10. Then that's a nice way to do it. Usually we don't do 1,000, but you can. All right, the last example. So you don't have to write this example in your notes. I just wanted you to see there was a shortcut. Last example 3 is with mixed numbers. So an example using mixed numbers. So again, this is a shortcut. If you have a mixed number, you can split it up, rewrite it as a whole number plus the fractional part. And then the 5 is a 5. You don't have to change that to a decimal. You know that you're going to end up with 5 point something. And the decimal piece is this fraction, this rational number. So if we do the long division with just that part, rather than changing it into an improper fraction and making the numbers really big, this is a simple shortcut. So 8 goes into 50 6 times. So that's 48. 2, 0, 8 goes in twice. 16, another 0, 5. So that, and then that terminates, because that's going to be 40 with no remainder. So there's my 5.625. So that's faster than, I believe, doing 45 over 8 and trying to do the whole thing in division. All right, so your 3 practice problems. 3 over 5, negative 7 over 10, which you could use that shortcut on, and then the mixed number, also you have a shortcut. And as always, the wrap-up summary. Okay, I kept it under 15 minutes. Nice.